All right, welcome to today's webinar, AWS Database Migration Service and Amazon Aurora, Migrating and Modernizing Mission Critical Databases. We're going to get started in just a few minutes, but we'll give a little bit of time for people to roll in. So again, just kind of sit back, grab a water bottle, and we'll get started here very soon. All right, welcome to today's webinar, AWS Database Migration Service and Amazon Aurora, Migrating and Modernizing Mission Critical Databases. I am Jay Martin, your host for the next hour. Certainly, if you have questions throughout today's presentation, please add them to the Q&A section on the right side of your screen, and our team of experts will do their best to answer each before the end of the webinar. I am very pleased to introduce a couple of very smart gentlemen, Jonathan Trelles from Amazon Web Services, and Craig Nelson, one of the fine solutions architects at ClearScale. Craig, if you would give a nice introduction to ClearScale and a quick overview of your role as well.
All right. Hey, y'all. My name is Craig Nelson. I'm a solutions architect here at ClearScale. ClearScale is a premier consulting partner with AWS, which puts us in the top 3% of all the partners in the AWS ecosystem. So our services range from architecture and design, cloud migration, application design, all the way down to support and managed services, really whatever you need. We do hold 10 AWS competencies, which is a program designed to identify and validate partners that have demonstrated AWS technical expertise and had proven customer success in a given area, which really just means that we spent a lot of time developing expertise in those areas, from data and analytics, migrations, DevOps, and more vertical specific topics like healthcare, education, nonprofits. You can actually see them there on the right. As far as the team goes, the vast majority of our staff is supremely technical in nature. We've actually done over about 1,000 such projects with AWS. We like to say we were born in the cloud. Our focus is and has always been 100% AWS, so we don't spend any time with other cloud providers, and make sure that we're on top of and moving in lockstep with AWS at all times as their services evolve. What that really just means is that we have the experience and expertise to make your AWS cloud initiative successful, no matter how complex your needs are.
Excellent. Thank you so much, Craig. And now, Jonathan, if you would tell us about this AWS I keep hearing about.
Yeah, sure. Good morning and good afternoon, everybody. Thanks for taking the time to join today. So I'm Jonathan Trelles. I'm a migrations solutions architect based in the East Coast in the US. Our team oversees the migration competency, and we actually work with customers and migration partners on implementing secure and cost-effective and efficient architectures. And we have an ongoing partnership with ClearScale and other migration partners to ensure that they can be an extension of our team when it comes to migration projects and challenges that customers face.
Perfect. All right. Well, today we have a three-pronged approach to the webinar, and we'll go ahead and get started with Craig introducing everyone to the many uses of Amazon Aurora. That will then pass it over to Jonathan Trelles, where he'll begin telling us how we can break free from legacy databases. And finally, we'll see a live demo of how easy this can be for you and your business. Craig, if you would go ahead and kick off with an introduction to the powerful and very much useful Amazon Aurora.
Sure. So I guess start with the baseline here. So what is Amazon Aurora? Well, it's a MySQL and Postgres compatible relational database built for the cloud. So it's going to give you the security, availability, reliability of a commercial database for a fraction of the cost, which is always nice. It's a fully managed relational database, which automates much of the time-consuming administration tasks, and puts that burden of the infrastructure management right back on the shoulders of AWS. You can focus on your business. AWS worries about the administrative details like patching and backups and things like that. We're going to get into some of the cool features here in a minute, but suffice to say that it's designed for It's designed for everyday use, for heavy use, giving you the performance and scalability, durability, all those things to ensure that the database, and more importantly, your data is there when you need it. So as far as how it does it, it's got a distributed storage layer underneath the covers, which provides for a bunch of cool functionality. And I'll hit on some of the high points. So like crash recovery, fault tolerance, self-healing storage. Aurora replicates your data with 2 copies into 3 availability zones. So you get 6 copies of your data in total, and it can survive an entire availability zone outage without any interruption, performance issues or data loss. So if you have read replicas, Oracle will upgrade the reader instance to become the primary and automatically route the traffic in the event of some sort of outage. If you wanted to do that same sort of thing on RDS or an EC2 deployment, it's going to take a bunch of effort, a bunch of manual effort, more importantly, which turns into minutes or hours that your database is down. Aurora can perform this action in the order of seconds. And if you have cluster cache management enabled, which is a feature you can enable at spin-up, you can even eliminate the cold start problem by ensuring that your failover's cache is even kept in sync with the hot primary. So if there's some sort of issue, you can recover within mere moments on Aurora. It could be a lot more difficult if you used other options, even AWS native options. Another thing they have is fast database cloning, which allows you to stand up a new cluster cloned from an existing cluster without actually copying the data. So it's more or less instantaneous. And it essentially does a diff on the data. If you make changes to your production database, the clone doesn't have those changes. If you make changes to the clone, those changes aren't replicated over the production instance. So you really have 2 independent instances with essentially a single storage layer, shared storage layer underneath the covers. It lets you do some really cool things like experiment with schema or parameter group changes. If you want to monkey with how the database is operating, you can do that on the clone and see how it operates without actually touching or risking your production database or even taking an outage. You can also take a clone of your production database, put it into a lower environment, or do some load testing against it. Or if you're trying to replicate a particular issue, maybe your dev data set doesn't quite have that same anomaly in it. Well, if you just take a clone of your production database, you'll have all the exact data you're looking for. Another really cool feature is the database backtrack, which lets you essentially roll back the database to a consistent state in the past. So imagine your table was dropped accidentally. Backtrack lets you rewind that database to a point in time prior to being dropped. It's similar to a database restore, but it happens much more quickly and with minimal downtime since it doesn't actually require spinning up a new cluster. You can roll back the database or backtrack the database a configurable amount up to about 72 hours. And you can also backtrack a database clone independently of the master, which could really be handy in some troubleshooting situations. That backtrack feature is really neat. Another cool feature about the distributed storage that it gives you is the ability to do these continuous backups and point-in-time restore. So Aurora backups themselves are continuous and incremental. So you're always really backed up, and you can restore to any point in time within that backup retention period, which is about 35 days. Beyond that, if you took a manual snapshot, you can store those in S3, and you can restore to any point in the past as long as you had a snapshot for it. But the important point here is that the backups are continuous. If I needed to restore to 17 hours and 53 minutes ago, no problem. You can do that in Aurora. Another nice feature of this is you can easily test the validity of your own backups. If you ever had to restore and found out your backup was no good, you realize this is a pretty cool feature. You can easily spin up a test cluster or a load test cluster, or you can dry run your DR scenarios without needing to buy additional hardware. Or introducing the chaos monkey to your production environment if you're the risky type. Another nice feature is that the storage scaling is independent of the compute. So when you spin up your Aurora cluster, you have to provision the compute power, obviously, but you don't need to provision up front your storage needs. Aurora manages it for you. So as you add storage to the database, Aurora volumes are going to grow automatically to the amount of storage that you actually need. And if you need less storage for some reason, if you decide to purge off some historical data or something, Aurora is going to reclaim that space, so you're not charged for space you're not using. It just allocates the storage as you need it, which means that you do not need to pay for storage capacity that you might one day need. If, for instance, you were in your own data center and you were contemplating buying a very nice branded storage array, you got to buy as big a storage array as you might need for the duration or for the lifespan of that unit. With Aurora, you get to just decide sort of on the fly how much storage you need, and you pay as you go. And the last item I've got here is read and write scalability. If your application is read heavy, Aurora allows you to create up to 15 read replicas across multiple availability zones. Take that load off the primary database. It'll still handle the writes, but all the reads can be directed to this nearly synchronous read replica, or set of read replicas that are load balanced, and take all that burden off your production database. And they can also facilitate some of the fast failover mechanisms, which I mentioned earlier. An important point is that like RDS has the read replica concept, but they can't automatically be upgraded to the primary in the event of an outage. So Aurora gives you a little bonus here. You'd have to take manual effort to do that on RDS. And if you really need to push the limits of performance in terms of read and write scalability, Aurora does support a multi-master configuration where multiple nodes can handle database read and write traffic simultaneously. So it's a flexible little tool. Quite nice. You should consider it. As far as some of the pricing, it's enterprise database and open source pricing. I mentioned earlier that it's MySQL and Postgres compatible, which means that your code, application, drivers, all the tools you use today can be used with Aurora with really little or no change. It also delivers 5x the performance of MySQL and 3x the performance or the throughput of Postgres. So if you're using Postgres or MySQL today, you should really be considering what Aurora might be able to do for you from a performance and throughput standpoint, not to mention all the backup and recovery things we just talked about. It is a managed service, as I mentioned, which means you get to focus your time and energy on your application, your business, and less time on database infrastructure. It's being compatible with Postgres and MySQL. You get the benefit of open source software, and the fact that it's widely adopted means that all the throughput and availability and all your reliability your enterprise requires is supported by by that open source community. And you really only pay for what you use, since it's a managed service. If you need more storage, you don't have to buy that $1 million array. Aurora scales it for you, as we talked about. You need more compute, you can scale up with just a few clicks, rather than going through a whole procurement cycle, buying only the hardware you need. That will soon be outdated. Aurora is going to really solve that problem for you. And you don't need to size for your peak demand. You can scale up as you need it for that one Black Friday season of the year. If you're a retailer, you don't need to buy all the hardware in the world to support that that 1 week of shopping when you don't need it in February. And of course, you can scale down as you need as well. So, buy the numbers with Amazon Aurora. Here's a couple fun call outs, really sort of highlight some of the power of Amazon Aurora. You can store up to 128 terabytes. Then you can compare the cost of that versus a storage array. Comes out to about $12,000 a month at 128 terabytes versus $1 million storage array for capacity you might not ever even need, or at least not need for a long time. You can scale up. Storage scales with use. No downtime or maintenance is required, as we talked about. There's a 10 gig minimum, but that's probably not a limitation for a lot of folks. The database recovery, Aurora replicates your data, all over the place. 2 copies into 3 availability zones, so you get 6 copies. You can survive a nuclear event with minimal issues, and no performance degradation, no downtime, no data loss. And then the sharing of snapshots, we didn't mention that earlier. But you can take these database snapshots and share them with up to 20 AWS accounts. You can actually do more than that if you contact support. But one of the a couple cool use cases for that is the separation of environments. If you want to, take a snapshot of your production environment and share that down to dev or test, that might be a good use case. Or if you're partnering with someone who needs access to that data, you can take a snapshot of your database and share it with all sorts of other external accounts and let them do what they will with your database. I can think of a lot of use cases for that. Research institute might be something where you've done a bunch of research and it's time to hand it over to the next person, maybe validate what you've done or take it to the next level. A snapshot is a perfect use case for that. With that.
Excellent. Thank you so much, Craig, for that overview on Amazon Aurora. Before we dive into our next section, we do have a quick poll question. What is the continuity plan for your database workloads? We'll give just a few seconds for some answers here, and then we'll get on to the meat of our presentation, where Jonathan Trelles is going to provide a demo and break down how we can break away from legacy databases. All right, some of the results that have come in. Tier 1, getting some responses, mission critical databases that require an RPO of less than 15 minutes. And then also D, I'm currently assessing the business continuity plan for my applications and databases. Jonathan, before we move on to your section, any thoughts on this question and these answers?
Yeah, those are good responses, and we can see the results coming in. Now the option D went up to 67%, so assessing the business continuity plan of your database and applications. And yeah, that's a good thing. I mean, part of the discovery phase during migration engagements or projects actually include, doing an assessment of your environment to make sure that we can capture the RPO and RTO requirements, and based on that, we can propose a potential database structure. But either way, like Craig indicated, Aurora can be optimized to actually meet that need, whether it's a tier 1, tier 2, or 3 database criticality tier, or if it's something that we can always customize in a development environment. And during the demonstration, I'll be showing you the baselines on how we can actually optimize Aurora to be in a production environment or in a development environment.
Perfect. Again, if anyone has questions, you can submit those in the Q&A section on the right side of your screen at any time, and we'll cover them at the end of the webinar. But now that we have an understanding of Amazon Aurora, Jonathan, if you would walk us through breaking free from legacy databases.
Awesome, and thanks, Craig, for the great presentation on Aurora. Before we get into the use case of migrating a database into a cloud-native AWS service, let's talk about some of the reasons why some customers are trying to break free from legacy databases. And actually, we have some points here on the slide. I think that the first and most important lesson or reason why customers are breaking free from legacy databases is to optimize scalability and performance. So with cloud-native databases like Aurora or DynamoDB, those databases are optimized for large-scale environments of the cloud. And an example of this is something that Craig mentioned in the beginning, right? Where you can actually write and do writes on your Aurora database to actually include those across 6 nodes or storage nodes deployed across 3 availability zones. So that's something that is going to help you improve your performance and scalability. Another reason is to reduce the operational overhead. So with traditional databases, we had to have dedicated database administrators that work on database patching, operating system updates, especially Windows updates that usually take a long time to run. And also they had to work on failover plans and backup and recovery to make sure that whatever mechanism you have in place meets your RPO and RTO requirements. So by moving to a cloud-native database like DynamoDB or Aurora, your database administrators can now concentrate on things like schema design and query optimization to kind of work to optimize your business, so you can release features faster and be ahead of the competition. And the last reason is to avoid restrictive licensing and contracting agreements. With traditional databases, licensing is usually fixed, regardless of how much you use of that license or CPU cores, and that can limit the flexibility to scale your database up and down. So that's one of the reasons. So we know the why now, and now that we decided to move to a cloud-native database, it is important to do our research and consider a number of factors. There are many factors, but I think that the 2 factors on the slide are the most important ones. The first one is going to be the database type. So as you guys know, in recent years, NoSQL databases have been actually gaining traction in the database space. NoSQL databases like DynamoDB have been popular because they often remove, some of those relational database constraints like schema requirements or foreign key validation and whatnot. And usually these features are disabled for high-scale applications because of their negative impact on performance. So that's the reason why sometimes NoSQL databases could be the perfect choice for your application. In any case, moving away from a legacy relational database to a cloud-native NoSQL database will require a lot of re-architecting and data design to make sure that the application code can actually work with that persistence or that database architecture. However, but for some companies, they may have some use cases that require strong consistency. And for that, a relational database is a perfect database to choose. And for that, Aurora can be a great option. So by moving to Aurora, you get all the benefits of a relational database in the cloud, and all the benefits that Craig explained during the first portion of the presentation. But I think that the most important factor to consider is what migration options we have. Because moving something from a data center to the cloud could be a very confusing or daunting task if we don't know what we're doing or how we're going to approach that migration. And that depends on the data set that we're going to migrate as well. We have to make sure that the data migration is handled properly with minimal downtime to the users that are actually using the application. So we at AWS offer, a large number of service options to ensure that you have a smooth, database migration experience. We can leverage AWS Database Migration Service, or DMS, and that's what I'm going to be demonstrating over the next few minutes. Migrating a MySQL database running on-premise on a Linux environment to a cloud-native relational database like Aurora. But if you're doing a database migration from different source and target engines, database engines, we can leverage something like the AWS Schema Conversion Tool, or SCT, to handle the differences in schemas between the source and target database engines. Now, there are more options, but if you need hands-on technical implementation assistance from database migration experts, we have a number of professionally managed options, like professional services. But we also leverage migration competency partners like ClearScale to help customers with many migration challenges. So that sets the preamble for breaking free from legacy databases. Now let's go into one of the use cases that we see at AWS, where a database needs to be migrated from an on-premise environment, and that database runs on an operating system, Windows or Linux, and the customer is looking to migrate to a cloud-native relational database. By doing this, they'll take advantage of the benefits that Craig and I mentioned before, improving the performance, scalability, and also the operational overhead will be reduced because we're not dealing with patching the OS anymore or the database engine. So this is going to be the blueprint that we're going to follow. We have our source database on the left. CentOS is the operating system, and the database engine is MySQL. And then the target is going to be on the right, which is that Amazon Aurora database. And then that section in between is going to be our DMS, Database Migration Service, which includes three main components, as you see on the slide. The replication instance is one of them. The replication task, which is going to move the data from point A to point B, and then the endpoints for the source and target databases. And we'll be walking through the components as we do the demonstration. So I'm going to switch to my remote desktop window here so you can see the demo. Let me get this done right now and see if this works. Can you see my remote desktop window?
It is available now. You should be seeing it just any moment now.
Awesome. I'll wait a couple of seconds for the window to come up on the screen, and then we'll get started.
Yep.
Can you see it?
Everybody should be seeing it at this point.
Great. Awesome. So we talked about the reasons why breaking free from legacy databases could be an advantage to your business, and we explain how Aurora is very beneficial for cloud native applications and the benefits that you get. But let's go ahead and visualize now how we can get it done and migrate a typical database from point A to point B. So we talked about the source database here, which is CentOS running on MySQL as the engine. And the goal is that we're going to move that database to the right to Amazon Aurora. And then we're going to have to set up or configure the DMS components. the replication instance, the task, and the source and destination endpoints. So let's go ahead and get to that now. And if at any point my screen, lags, just let me know. I'll be happy to go back to that step. But I want to make sure that everybody can visualize the migration end to end. In any case, the first thing we have to do is we have to ensure that we identify our source environment. So we do have a database server already configured with the operating system and the database, and that is on the screen right now. I'm actually connected to that server right now. The other thing we have to do is we have to configure the target database, and that's the database that's going to be the database is going to have our data. So let's go ahead and do that now. And let me go to the console real quick and create that database. Now, as Craig mentioned before, Aurora has the ability to do MySQL or Postgres compatibility. And we have the option to set up the capacity type, and that can be provision, where we actually manage the server's instance size, or we can do a serverless type, and that's in case we want to automate the auto-scaling based on the usage. And that is good for infrequent or unpredictable workloads. So little to no capacity planning is needed if we actually go serverless. For the demo, we're going to keep it as provisioned. We keep going down the options, and then these are the replication features that we talked about, and Craig indicated this in the beginning, where the single master can have one writer endpoint and up to 15 reader endpoints. And then the multi-master is the one that supports multiple writer instances. But anyway, let's keep going down the list. And this is the baseline that we talked about. And that was something that we connected during the database criticality poll question. We offer templates or baselines for you to pick and choose the best implementation of this database. We have production and dev and test. So for this demo, we're going to select dev and test just to keep it simple and go through this demo and to ensure that we can finish the demo in the time that we have. Then we specify the database identifier, the credentials like username and password, and we get into the database instance size. And this is where you actually choose the performance of your database. You can actually choose between memory optimized or burstable, and the options are there in the drop-down menu. And these options actually change based on the template that you select at the top, whether it's production or dev and test. So we're going to keep going down, and this is the availability multi-AZ deployment options that you have, and then setting up the VPC where the database is going to reside, the subnet groups, security groups. And under additional configurations, we have the option to enable encryption and monitoring. So with encryption, we can actually do encryption at rest by doing KMS. So if I go into that option, you see that we have the option to check this and select the key that we want to use, which means that our backups, snapshots, and replicas will be encrypted with the KMS key that we select. Now, we also have the ability to do encryption in transit via SSL, and this works the same way as you encrypt, in transit traffic to your MySQL or Postgres databases. It'll work the same way. The backtrack option is what also Craig explained. It's the point in time restore that you have. So you can check that box and enable it if you want, based on your need. And then you create a database after you complete the configuration. Now, the creation takes about a few minutes, but for the demo, I already have a blank database with the settings that we actually configured. I set up the database to be a DB-T3 medium with the dev and test profile. So let's go ahead and click on that and explore. And this is going to be the writer endpoint. So let me go ahead and select that. And what I can do now is I can actually connect to that database so I can check and see the configuration. So let's go ahead and do that now. MySQL, and the username I set up is admin, and the host name is the writer endpoint that we cut and paste. And I think there is something here with the copying and pasting that didn't work properly. Let me do this through Notepad. Challenge of working with remote desktop. So, and then we set up the password. And the password is the super secret password that I set up here, password 12. And we're logged on to our Aurora database. So now let's go ahead and connect to the database, the WordPress database. And if we do a show tables, we can see that we have no tables in the database, and that is because it's a blank database that we created. So the goal is going to be to move all the tables and the schema from this source database to our newly created Aurora database. So we're going to go ahead and do that now. Okay, so let me clear the screen. Quit and then clear. Awesome. Now we can go into DMS. So to be able to launch the DMS replication instance, which is going to be the instance working on the replication task to migrate the data in the schema, we have to make sure that we set up a DMS subnet group to ensure that we specify which network and which availability zones are going to be leveraged for this migration. So let's go ahead and do that now, and it's something that we can do fairly quickly. So we can go and create the subnet group, and let's go ahead and give it a name. So I'm going to use WordPress subnet group just to make sure that we can identify it. And the VPC is going to be our target VPC for our migration. And then the subnets, they have to be across two availability zones. So I'm going to select the private subnet, and I'm going to select the Aurora subnet. So as you can see, we have 2A and 2B, so they're being deployed across two AZs. So we create that subnet group, and it's already created. So the next thing we have to do, going back to our graph, is to make sure that we set up the replication instance. And this is the first task in migrating the database to ensure that our replication instance has the sufficient storage and processing power to perform that database migration from source to target. So let's go ahead and do that now. We go into DMS, go into replication instance, and then we're going to create the replication instance. We're going to give it a name, and we can say something like replication instance, WordPress. Description can be the same. The instance class is something that I mentioned before. It has to be something that can accommodate the compute capacity plus the storage for a database. So I have a small database that I'm migrating, so DMS T3 medium should be sufficient, and 50 gigs of allocated storage should be fine as well. So I'm going to keep going down the settings. And I'm going to uncheck the public accessible option here and check the target VPC, which is where this database is going to be migrated to. So my landing zone. Keep going down the list and go into the advanced security and network configuration. And this is where we actually link that subnet group that we created before to our replication instance. And then we select an availability zone, and then we select the security groups that we want to use for this migration. So again, I already have a landing zone already deployed. So I'm selecting the ones that I need for the migration to be successful. Likewise, we have the ability to encrypt that resource with KMS. We're going to leave that as default for now. And then we create the replication instance. And that's going to take a few minutes. So let's go ahead and go back to the graph. We created the replication instance. The next thing we have to do is make sure that we set up the source endpoint and target endpoints. And then we're going to set up that replication task to link the source and target endpoints. And the replication instance is going to be doing that work behind the scenes to migrate that data in the schema from the source to target database. So while we wait for that replication instance to be created, and it's going to take a couple of minutes, we can actually go and start creating the endpoints. So we go here, and we're going to begin with the source endpoint. So it's going to be this endpoint right here. So we create the endpoint. We select source endpoint. We're not doing a RDS database as the source. We're actually migrating our on-premise database. So we're going to leave this box unchecked. For the identifier, let's go ahead and use something that makes sense, like source WordPress. And then the database engine is going to be MariaDB MySQL. We keep going down, and the server name is supposed to be the IP address of the on-premise environment. So let's go ahead and do an ifconfig on the server on-premise, and this is the IP address. So let me copy and paste that. And there we go. The port is going to be 3306, which is the standard MySQL port. And we have the option to enable encryption. We're going to leave that as none for now for the demo. And let's go ahead and set up a username and password. It's going to be WordPress, which is the username for the on-premise environment. And the password is going to be the super secret password that I have set up here before. We're going to copy and paste this. All right, so we keep going down the options, and we set up the VPC that we need. So it's going to be the target VPC. And the replication instance is going to be the newly created replication instance that we actually deployed before. So let's go ahead and check on the status of that replication instance. And we can see that it's still creating. So we'll give it a few minutes. In fact, if we actually try to run the test to make sure that we do a pre-verification before creating the endpoint, it's going to fail saying that the replication instance is not active. So we'll give it a few minutes. It should be done fairly quickly. Just to go back to our graph, we are setting up the source endpoint. And then the next step will be to set up the target endpoint. And then after the replication instance is done, we're going to work on the replication task to migrate the data and the schema from source to destination. So let's go ahead and give it a few minutes. And while we actually wait, we can talk about the database migration task briefly. But that's where all the magic happens and all the work. We specify what tables or views and schemas need to be used for that migration, and any associated processing like login requirements, control table data tables, and whatnot. That's specified during the database migration task. And we'll be doing that as well during the demonstration. Awesome. So we can see now right on time that our replication instance is complete. So now we are good to go to run the test. And it is testing now. This should take a few seconds. But what it's doing is actually checking that all the configurations that I've done here on this page make sense. And that is something that is going to be working when I get to the point of running that replication task. So we'll wait for that testing to be complete. And it gives you that warning saying that, we run the test, and then if it fails, the endpoint will still be created, but you can retry the connection again. So let's go ahead and wait. And it has been successfully created or tested. So let's go ahead and create the endpoint. And the other thing we have to do, like I said, is create that target endpoint. And this one should be much easier because we have already an existing Aurora database, which is the one that we created right here. So we create the RDS instance, which is the Aurora database. We select that database from the drop-down menu. And then we'll give it a name that makes sense. So let's go ahead and call it Target WordPress. And then we'll leave everything as is. And the password is going to be the same password that I used before to make sure that we have consistency during the demo. We keep going down the test or endpoint connection settings. We select the VPC that we need for my landing zone, which is my target VPC. And then the replication instance is going to be linked to my WordPress replication instance that I created. Again, same process, run the test. And now it should be pointing to our replication instance that we created before. It should take a few seconds. And the next thing we have to work on is the replication task. And that should be fairly quick as well. and has been successfully tested. Now we can create it, and we are good to go to create that replication task. So let's go ahead and click on that. We're going to create the task, and let's give it something that makes sense, like WordPress, MySQL to Aurora migration. The replication instance is going to be, again, that replication instance that we created. The source endpoint is going to be our source WordPress endpoint. Our target is going to be that target WordPress endpoint. And then I'll come back to these options in a minute, but we'll leave it to migrate existing data for now. And then we do have the option to actually drop tables on the target database, truncate, or do nothing, and also how to manage large objects. In this case, we're going to leave everything as default with the limitation on large objects to 32 kilobytes. So we're going to leave it as that. And then this is the section that we have to make sure that we set up properly, because this deals with the schema and table mappings. So DMS uses your selection rules to determine which schema or tables you want to include in the migration task. And we can specify multiple selection rules. But in this case, I'm going to just keep the wildcard selection rule to make sure that we migrate the entire schema as is, because we're going from a MySQL database to a Aurora MySQL compatibility. So we enter the schema, put in the wildcard, and then we keep the action as include. All right, so we keep going down, and then the last option is to start the task or the replication task as soon as I create the task, or I can schedule that later. So we're going to leave it as is for now. Create the task, and I think I specified, there we go. I clicked the button twice, and that's the reason why it gave me that message. Let's go ahead and do that. And it should be creating that task. Great, so we'll wait a few minutes for that to be created. But anyway, we are migrating a MySQL database to Aurora in MySQL compatibility. But if you're coming from commercial database or databases or data warehouse schemas, then we can leverage something like schema conversion tool to make sure that the source schema matches to the AWS native service like Redshift or Aurora. But we'll wait for this guy to complete. And when we actually wait for that, we can check the replication instance is actually doing some work. If we go into the metrics, we can see it spiking up. And then if we go into migration tasks, we can see that it is associated to the migration task or replication task that we created before. So we'll give it a few minutes and we'll wait for that to finish. But if you go into the replication instance and go into the migration task, you can actually see the migration task, and you can see the source and target endpoints that we talked about before, when the replication was started, when it finished, and all of that good stuff. Anyway, going back to our graph, we finished the replication task, and then now it's doing that data load between source and target. And the last thing we'll have to do is point the application to our newly created database for that application to be getting that data persistence from the Aurora database. So I think it just finished. That was really quick. Let me double check. Yep, and the load has been completed. If we go into table statistics, we can see all the tables that were migrated as part of this migration. As you can recall in the beginning of the demo, we logged on to the database and it was empty. We had an empty set. So the way to verify that our migration was successful is to, again, log into our database. And the table here, or the tables here, should match the database when we log into it. So let's go ahead and do that now. And I think I'm going to use Notepad again because I had issues with cutting and pasting before. So go back here to MySQL. User is admin. Host is our writer endpoint, and port. So let's go ahead and do the same commands. Use the WordPress database. And then I'm going to show tables. Great, so we can see some tables that were migrated now to our newly created database. And in fact, if we go into our DMS and go to our database migration task, we can see that the tables match and that our database has been successfully migrated to our target environment. So this was for a small database, but it shows the simplicity of migrating, from a source environment to a cloud native resource. And again, just to recap, now that we pointed our application to our newly created Aurora database, which has our migrated tables and schema, we can shut down the source environment, and then slowly we can decommission the replication task and all the DMS configurations that we actually explained before. One last thing that I forgot to go back to is if we actually go into the DMS migration task, let me actually go back to the console again. There was the option of migration type, and we selected migrate existing data. So this only does a one-time migration from source to target environments, but there are other options, as you can see on the screen. We have the option to migrate the existing data and replicate ongoing changes. And what this is doing one big one-time migration from source to target, and then it's doing that replication, ongoing replication as well on the different commits that you're doing in the database. And then the last option is if you actually you don't want to do a one-time migration, but you want to continue the replication, you can actually select the last option as well. In any case, this shows the simplicity of migrations from a source on-premise environment to Amazon Aurora. And as you can see, our newly created database has the schema and tables from our source environment. Hopefully you found it useful. And having that said, let me go back to the slide presentation here so we can resume the webinar. And it should be coming up soon. And go ahead, Jay.
Perfect. Thank you so much. I thought that was great. And it's, impressive that in a matter of 30 minutes, I feel like I could go through all those steps as well. So as we kind of proceed on, Craig, if you would just go ahead and continue talking about Aurora here, where we get to see that Aurora is kind of taking the world by storm. And there's quite a bit of momentum, and then how ClearScale can certainly assist.
Certainly. Yeah, so Aurora has definitely got momentum. There's that slide would suggest a lot of big name logos there. Of course, it's not only for big name logos. If you're a moderately sized logo or a brand new logo, an up and coming logo, there's a really good chance that Aurora is the right solution for you. The momentum speaks for itself. We've got a couple clients that we've actually implemented Aurora, done migrations for. We can take you through those real fast before our time here is up. First up, we have the Sierra Club. They've got a public-facing online advocacy platform. They didn't have the flexibility that they'd like due to some design choices in their management structure. So the challenge was that they'd had a third-party MSP who was responsible for all their AWS services. They gave them a lack of visibility, lack of access, no control of the environment. It made troubleshooting hard. So in addition to that, they had performance issues with the environment and challenges scaling their MySQL database because they didn't really own it. So the solution was to have ClearScale. We came in and built out a new architecture in Sierra Club's own AWS account. We migrated the databases to Aurora MySQL using the database migration service, as you just saw demonstrated. And we leveraged some other AWS services such as CloudWatch to help the IT leaders monitor their system and resource usage. Really, they gained visibility into the performance and overall health of the system that they did not have before. And the result was that they gained control of their online platform. And by migrating to Aurora, they gained the ability to scale the database more or less at will, not to mention the performance boost that they got simply by moving to Aurora. So the whole thing is now much more agile thanks to the new AWS infrastructure. So that was it was a success for a number of reasons, not the least of which was the inclusion of Aurora in that migration. So we did a similar thing for a client called Entropics, who you may be less familiar with, but they've got their computer vision software company. They use AWS services to reconstruct video and do cool CSI type things on improving. If you've ever seen the old enhance meme, I guess that's what Entropics really pulls off in real life. But the challenge was that Entropics wanted to deploy a new on-demand software as a service architecture for their video processing engine. The existing system was Postgres on EC2, which meant they had VM administration, manual effort for backups. Scaling was non-trivial, of course, and really just required manpower and effort to support. And they had limited visibility due to the cloud native monitoring, and the team had limited experience with AWS. So that was another, obstacle they had to overcome. The solution was that ClearScale modernized and refactored layers of the application into elastic autoscaling groups using ECS, or the Elastic Container Service. We decoupled the application using the Amazon's queue service, and we dynamically autoscale the application by monitoring the queue depth. So really, as more messages went in the queue, the app would scale up until it processed through that queue, and then it would scale itself back down. It's pretty neat. We transitioned them off Elastic Block Storage and put them on S3, which is considerably cheaper and scaled a lot more easily. But I think the headline of why we're all here is that we migrated them from that EC2-based Postgres instance to Aurora Postgres. We took advantage of multi-AZ configuration to facilitate better availability and get those DR capabilities that we talked about. And those management tasks for backups and patching, all that stuff became AWS responsibility. So really took the burden off Entropics. So the result was that the new architecture was built to scale along with the demand, which they didn't have before. And their capabilities are now open to a much larger base of customers, which is sort of the point in the first place. And then using those AWS managed services allowed the client to spend less money and time on infrastructure and more time and effort on their core business. And who wouldn't want that? So how do we get there? ClearScale's got some migration offerings. It's really a sort of a 4-phased approach to how we do it. And the first phase there is database strategy and assessment. Typically 3 to 6 weeks, and we'll build out an assessment report and come up with a migration refactoring plan. We'll use that schema conversion tool you saw to perform, schema conversion POC and produce a deployment plan. So that takes, a couple weeks, and then we will quickly move on to, the moving to the managed database, where this could be 8 or more weeks. Really, it becomes a function of, how big your project is from this point forward. But we'll optimize that data migration strategy. How we're going to get from point A to point B. Can we just copy the data up, or do we need to rent a snowmobile? We'll begin migrating that data either online or offline, while the legacy database remains running and the source of truth. And so we can test performance, sort of in parallel, and optimize whatever needs attention. And then we move on to step 3. The legacy database migration usually takes at least 12 weeks, but it can really depend on the size and complexity of your system. This is where we actually do that the migration of the database engine. You're refactoring and stabilizing your application code to make use of the new database. And ideally, you're eliminating, or at least lowering the costs of your database licensing needs if you're coming off a more name brand database. And the last step there is really this sort of takes you off into the stratosphere, the database modernization and deployment. And this can take really 12 or more weeks. Depends on what you want to do, how deep into the woods you want to go. But it involves the architecture reviews and design documentation, understanding what problems we're actually trying to solve with a modernization effort. Creating a migration plan, how we're going to get there, incorporating necessary application refactoring, leverage a new database backend, which could really significantly alter how your app interacts with the database. If you're going to go to introduce NoSQL type components, then things are going to look a little differently than they do today. And then actually execute that database migration. It's probably a little harder than we've made it look here, but the thing to remember is that ClearScale and AWS, we're here to work with you every step of the way. Go ahead and please leverage our expertise in this arena, make your migration successful. Everybody wins.
Excellent. Thank you so much, Craig. And certainly as we're kind of wrapping up this evening, we've got questions that have rolled in, starting with, it was mentioned during the presentation that Aurora replicates the database volume 6 ways across 3 availability zones. Does that mean that I have to pay for 6 times the price of the storage? John, you want to try that?
Yeah, I can take that on. That's a good question, by the way, because we did mention that twice. But the answer is no. The actual replication is bundled into the same price. So if you set up an Aurora database, you're actually charged based on the storage your database consumes at the database layer, not across the 6 deployments and availability zones that we do.
Okay, it looks like somewhat of a follow-up question. If I want to set up a replication between my Aurora MySQL database and external MySQL database, is that possible?
I can take that on as well if you want.
Yeah.
Yeah, so it is possible to set up bin log replication between an Aurora MySQL instance and a database running MySQL, externally. And we have the capability of running the other database on Amazon RDS, or a self-managed database on AWS, or something completely outside of AWS. So that option is there.
Perfect. And then how are AWS Database Migration Service, the DMS, and AWS Schema Conversion Tool, the SCT, related? You want to jump on that as well, John?
Yeah, that's another good question. So like we demonstrated during the session today, right? The DMS, or Database Migration Service, will actually help you with moving your data through that replication instance from point A to point B, right? And that could be, and something I forgot to mention as well during the presentation, is that the source and target endpoints that we deployed, those could be a on-premise server, or they can actually be a cloud native database, right? Like RDS. In this case, we had the source and target to be on-premise to RDS, but we can actually flip that implementation and do it the other way in case we need to migrate back to an on-premise environment. So that option is there. And that's what Database Migration Service is for. Now, when it comes to migrating something from different engines, like if we're actually going to do a database migration from, I don't know, Microsoft SQL into something that's cloud native in Aurora with MySQL, then we can leverage SCT, the schema conversion tool, to actually help us with that schema conversion and data transformation that we have to do. And that's mostly with the schema optimization, store procedures, and all of those associated things that come with different engines in the databases.
Gotcha. And then Craig, it looks like this might be a good question. If I know I want to migrate my database, why do I need to go through that initial phase that we have here for the strategy and assessment?
Well, it's probably never quite as simple as it sounds. The schema, the schema conversion tool is it's a fantastic tool, but you may have specific use cases or implementations that might not map cleanly, especially if you're coming from a non-Postgres database to Postgres. And so you're doing a POC on what your conversion is actually going to look like and where the gaps might be is probably one of the biggest reasons why you'd undergo that. But yeah, that's probably the best reason right there.
Yeah, prior planning prevents poor performance. So definitely think it's valuable to go through that strategy and assessment. Well, it definitely looks like we're up against the clock at this point, but should you have any more questions, please feel free to schedule a consultation with our solution architects by simply reaching out to sales@clearscale.com. A couple of great follow-ups to today. Discover the power behind serverless and containers on December 17th. So we'll have that invitation going out very shortly after this webinar. In that webinar, we'll explore the rapid growth of the cloud, optimizing cloud applications, features and benefits of both containers and serverless computing. And then next month, we'll have an entire slate of new webinars for everyone. But until then, you can always visit clearscale.com for all of our on-demand content, ebooks, infographics, and much, much more. Again, a very generous thank you to Jonathan and Craig for taking the time to help with today's event. Hopefully, we can get both of these guys back for more content soon. Also, thank you to all the attendees. We hope that you attend many more of these webinars in the very near future. Have a great rest of your week, and we look forward to discussing database migrations with you soon. Again, thank you so much, and we will see you at our next webinar.